I think he is in the middle.
What are you doing right now?
Yeah.
Seeing some very interesting organ structures there? I don't know. How do you? Everything fine? You see now he's doing his exercise. These are the exercises which all of you must do.
كيف بناك دكتور تصور نكتب هنا.
So you had a very serious issue on one of the important things, that is the normal distribution.
Yes.
Then there was some other concept which he put, that we have a normal distribution, something called the bell-shaped curve, isn't it? He told you?
Yes.
I'm sure he told you. He also told you something, no disturbance. He also told you something, that if we have that normal distribution, do you know what's normal distribution first? Do you, who says yes? Yes, please. What is normal distribution?
Normal distribution, that means all of the people get the chance to be involved in the
Study? That is sampling, not normal distribution.
yeah.
So that was sampling. I don't want it. I don't want it. I don't want it.
Yeah. Just
Escape.
okay.
Okay, you want to put this off. Okay.
Okay.
So when he told you about the bell-shaped curve, for example, understand my point. If I am going to, first you have to understand what's a variable. Do you know anything about variable? You have been reading it for last 3 years.
Yes.
Do you know anything is variable?
Yes.
What's variable?
Quantity and quality.
You can change it.
Define. One is called definition.
Variable.
Definition of variable. I never said quantitative one or qualitative one. I should define a variable. I said define a human being, not the female or the male. First define a human being.
Factor can be changed.
Yes. So variable is any characteristic. When I say variable, it means it is changing. The root meaning of this variable is any characteristic.
Change it.
So I am writing characteristic that takes different values. That takes different values. Now what is that? Characteristic that takes different values.
Finish it.
Are you getting anything?
Thank you.
Not yet. Not yet. Let me tell you one thing. If I have to measure the weight of all of you. This weight is called a variable. It's a characteristic. So what is the characteristic? Weight. But is it same in all of you?
No.
So weight is a characteristic that takes upon. So when it takes different values, we call it a. Similarly, if I am going to check your height, will it be same?
No.
So that means it is a blood pressure. It will be a variable. Now the other thing is whether it's a quantitative or qualitative. We will not discuss that.
Yes.
Because this is not my purpose today. So the purpose today is that what we are trying to have is a variable. A variable is any characteristic that takes different values in different people. Clear? So simple definition, huh? Easy to remember. Fine. So we are done with the variable. Now the question is, if I am asked to see the height of medical college students from grade 1 to grade 5 when you pass out, of all the world, that is the total population. So the medical students in all the medical colleges of the world is your population. Is population. If I take all the values, for example weight, all the weights of all these people, what I am getting is called a parameter. Is called a
Parameter.
So when I am talking about population, I am talking about a parameter. So I am taking weight. Weight is measured in what? How do you measure weight?
Kilogram.
Oh, absolutely. None of you are the bakara, but still you know. So you measure it in kilograms, isn't it? Now, what's the kilogram? Is it quantitative or qualitative? Measure it. Quantitative you measure. If you cannot measure, then it's a. So you can measure how male he is? No, that is a. So the gender is qualitative, and this is quantitative. Huh? You should enjoy your learning. Huh? If learning becomes boring, then it's not learning. Huh? So when this case is, okay, now I have taken all the population. This is called population, all the medical students of all medical colleges. So what I will be measuring is a quantitative variable. If I am going to tell you that the average weight of any medical student is like this, what I am calculating? Average.
Mean.
Mean. So I am talking about mean.
Mu.
Okay. So you are also a medical student in this whole universe. If I am talking what is the average weight of him, so I will take all the observations, I will divide by the number. So these kilo weights, this is a variable. This also we call a data. It's a quantitative data. What I can calculate from this is called a summary measure. It's called summary measure. They told you, Dr. Ashok, summary measure. They told you that mean is a summary measure. He also told you that mean is the measurement of central tendency, that which comes in the center.
Yes.
He told you. So that was, when we talk about all the population, we are talking about this one. This is called
Mu.
meow. Not
Meow.
not meow. Yes, absolutely. Not meow. Huh? That goes for the Billy. Billy means the cat. In Urdu we say Billy. But is it clear?
Yes.
If I took all these things, all the individual ones, and put it on an axis called x-axis. This is x-axis. Okay. So I'm putting it on x-axis, all the observations. This is the y-axis. This is here weight. For example, this is not the same picture. I'm giving you an arbitrary one. So this is the weight. This is the number of students in each category of weight. So when I plot like this, what I am getting is something called a normal distribution. So some people will be having lesser weight, some people have more weight, some people will be towards the center. Is that right?
Okay.
So when this thing happens, all of the population, then we say it's a bell-shaped curve. Why do you say bell-shaped curve? Because if we cut in the middle, this is the mean. So there are 50% observations. 50% of the students of all will be above this, 50% will be below this.
Below this, okay.
Is it clear? So if we superimpose on each other, it's just like a bell. So this is a bell-shaped curve.
Again, divided.
It's a bell-shaped curve where the peak is in the middle and this is a curve. And the curve tapers. It becomes smaller towards the edge. Is that clear?
Yes.
Fine. So in a bell-shaped curve, we have the mean in the center, 50% of the observations above, 50% of the observations below. So it is not only the mean, but it will be also the median which will be at the center. It will be also the mode. You know median?
Yes.
What's median?
The center. The middle one.
The middle student. I will range all the students, the middle one will be here, the mean will be also here, the mode will be also here. So we say all the three things will be at one point. At one point. Now I am giving you the example. Look, here we have 100 people. 100 people. 15 plus 20 plus 30 plus 20 plus 15. If you calculate them, they are 100. Is it 100?
Yes.
Yes, ma'am.
Fine. Fantastic.
Yes.
You are very good in calculation. So it's 100 because you are measuring your GPA out of 100. So what's happening here? These are called, Dr. Ashok told you, this is continuous one, isn't it?
Yes.
So which graph is this?
Again.
Which graph? G-R-A-P-H.
Bar.
Bar are separate, man. They are continuous.
Histogram.
These two.
Histogram.
So when you have a quantitative variable, you don't have a category. Quantitative means it continues.
Yes.
Simple means.
Yes, yes.
So you cannot have a break in between between these. These are called class intervals. He told you. Class intervals. So if I put, for example, I have taken the blood pressure of these 100 people.
Okay.
And the people who have between 90 to 95 are 15. Between 95 to 100 I have 20 people. Between 100 and 105 we have 30 people.
Okay.
And similarly up to this. These are called bins. Class intervals are bins. You have dustbin, big bin. Huh? You have small bins in the, in the home, but a bigger dustbin outside. So you take it and put it there. So these are the bins, or class intervals. So you have number of, so we have the blood pressure on the x-axis and number of patients or participants on the y-axis. Now, if you are going to just join them, what will you get? So Dr. Ashok told you, if you take the middle point, you will get a polygon. Isn't it? He told you, but you forgot. So now I will take also. So if I want to join, the curve becomes like this. Isn't it? The same curve of the students. The curve becomes like this. So the mean, if you take the mean, the median, you see. Now I will show you here. For example, these are 3 groups. There are 3 groups. But these are only 5 observations. These are not 100. Eh? It will be very difficult for you to calculate. One of the person has 100, another is 105. This is the systolic blood pressure, which you forgot to put it here. SBP. That means the systolic one, the upper one. So one has 100, 105, 110. Calculate what is this? How much is it equal?
550.
You have calculated? Sure?
Yes.
So divide that by 5. How many people are there? 5.
Yes. 550.
You have the, just calculate it.
Okay.
550.
Divide by number of observations.
5.
5, so it's 110.
110?
Yes.
110.
Yeah.
He also forgot to put a bar there. My friend, who was that?
Sample.
Oh, just check. It was x bar, x bar. So this was talking about the mu, which is about whole population, but when I take a sample out of that, I will represent it by x bar,
Okay.
and it's 110. What happens here? So this is the mean of the sample.
Okay.
This is the mean of the
Whole population.
population. Mean of the sample, x bar. I am taking another sample. So see what's happening here to this mean? Calculate second mean.
520
Divided by again? 5?
divided 5, 104.
Oh, 104. What's happened to the third one? That's the basic crux I want to understand.
640.
Divided by 5. He's a moving calculator.
128.
128.
128.
128.
Yeah.
This is millimeters of mercury. You measure it in millimeters or centimeters, mercury. So, if I put this one like this, if I have this type of observation, these are different observations.
Yes.
When I plot, I got a bell-shaped curve in which the median was there, mode was there, and median was also there. Okay. Now what's happening here? If one of this is the part 1, in part 2, this observation is lesser.
Okay.
When this observation is lesser, what's happening to the mean?
Change.
So if I make this plot, now this mean will come here. But what is the median? What's the median? The fifth one. 1, 2, 3, 4, 5.
Yes.
120.
So this third observation, does it change?
Yes.
No, no, observation number.
4, no.
No.
Okay. It is 5 number.
Hmm.
And the mean.
This is the third number.
Yes.
So it doesn't change.
No.
So it remains same. So if any observation is less, then what happens to the mean?
Change.
X will be decreased.
Change.
The mean will be decreased. So median will be, it will remain at its position.
Okay.
Understand my point? Very, very simple point. So they were all mean, mode, and median. This was for this observation. But then once I change this one value, I decreased it, what happens to the mean?
It will be decreased.
Okay, so mean moved here. But what happens to median and mode?
So this is changed.
So
Still-
I am
still-
more concerned with the median. It remains at its position.
Yes.
What happens to the third one?
Mode.
What happens to the third mean?
Same.
Increase. Increase.
So it will be, is mean increase or decrease?
On the
Increase,
right.
increase.
It is right.
So the mean is here now. But what happens to the median?
In the middle.
That means if you have smaller observations, the mean will shift towards
The left.
left, and if you have large any of the observations, the mean will shift towards the
Right.
but the middle one, 1, 2, 3, 4, 5, will remain the same. The third person will remain the same in the middle. Is that clear? Now, what is this called? This was called, now I will make it like this. This was called the normal distribution. Okay? Here the mean, mode, everything was at the same position. Now, what's happening here? Now, I am decreasing one of the observations. Okay? Now, when I decrease it, it moves like this. Because one of the values is very small,
Okay.
number of observations. And what happens here, one of the observations is very huge. So it will be like this. This is called, because this was a small observation here, this is called which side deviation?
Left.
Left skew. This is called as left skew. This is called
Right.
Right. Skew.
right skew. So what happens in left skew? In the normal distribution, all were there, all were in the same position, but this was the original position of mean, mode, and
Shift to right.
so what happens to the mean? Median will remain at this position, but because one observation is small, so the mean will go down. And here, now what will happen to the mean? Mean should increase, because the value is increased. So this was the mean, mode, and this, but once the observation, one of the observation was huge, 110, it shifted, mean shifted towards the opposite side. So the take-home message that we should keep in mind that in normal distribution, the population is equally distributed, the mean, mode, and median are the center. But once we have extreme values, very small values or very large values, the mean and median, they separate. They separate. What happens? In the left side skew means the tail is towards the left. And we have one of the observations small value. When we have one observation small value, the mean also decreases, so mean will be towards the left side. And when we have any observation which was large, then the mean shifts towards up. You see what was happening to the means?
Yes.
Is that clear?
Yes.
Difficult?
No.
Difficult or easy? No, I'm not getting a response now, which I should get.
It's called Doctor left what?
Left skew. One is called left skew and it's called right skew. So in the left skew, where is the mean, where is the median? You should know.
The
At the right skew, where is the mean, where is the mode, where is the mean and median? I'm more concerned with between median and the mean. What happens when the observation, values of the observation changes. If it goes, one of the values goes down, it will bring down the mean.
The median is in the middle.
Did it change?
The
Did it
mean,
change?
just the mean.
Did it change?
No.
So
Yes.
it didn't change.
Yes.
The position. What's median? What's median?
median thing.
Median is the middle one.
Average.
Did this middle, this third person, it did it. The middle remains there. The mean only changed. Because there are 5 observations. Is that clear?
Yes.
The left, the normal distribution, left skew, right skew, clear? What happens to the mean, what happens to the median, is it clear?
The question is going to be about the median and the left.
No, what is the question is something different. I am telling you, have you understood? Have you understood this or not?
Yes.
That's the point. Now, why, if you are asking a question, then I should give you a paper, no?
But the skew, the word, what does it mean exactly?
Skew.
Yes.
What does skew mean?
It's not identical.
Skew means that it's not uniform like this. One side is the tail, one side has been stretched out. That's skewing to that side. Is that right?
Yes, yes.
No issue with this?
No.
Clear?
Yes.
Fine. So I will remove this one.
Doctor,
Yes.
support.
There was stuff about extra about northern, middle, and mean in the lecture.
There's more also in there.
So we are going to speak about it or not? Because it just
You are only, what I told you, you have to speak about 2 important things. If you know the mean and the mode, you can solve any problem. What happens to mean, what happens to median. Have you understood that?
yes, it's easy.
Finish. No second question. Now, this was about the observations. Is that clear? So we know now the whole population, how does the observations behave, and we also know if it's not a normally distributed, then we will have either a right side skew or a left side skew, depending upon the individual value, whether it's too small or too large. Clear? Now there is another concept which they told you. They told you that, oh, okay, they told you we have a normal distribution. They also told you there is a mean in the middle. They also told you that there is another important concept which they put. They put something called a standard deviation.
Yes.
Now what is the standard deviation? You are being helped by Dr. Ashok to calculate that standard deviation. Now I am not going to repeat the calculations. Obviously not. I am not going to calculate that. That will be unfair for me to stretch again Dr. Ashok's lecture. Now what I will tell you, that it tells us that there is mean, there is something called as one standard deviation here, one standard deviation here. There is something called as two standard deviation. There is also called as two standard deviation. Okay? Now he tells us, Dr. Ashok tells us, that if you have any value, you must first understand that if we have a one standard deviation, either side of the mean, this is the positive side, this is the negative side. Is that clear? So the number of observations, these number of children, all the number of children, medical students, how much will be here in one standard deviation? From mean here.
65.
68.
68. So he told you that here there will be 68%. 68% observations. If I tell you what is the percentage of observations which are standard deviation plus 1, what is the number of observations here? What are the number of observations? Mean plus minus 1 SD. What are the number of observations?
34. Minus.
Okay, minus and plus, that means total was 68.
Yes.
If I tell you what are the mean plus standard deviation, one standard deviation. Mean plus one standard deviation. I have not put the minus one.
Okay. 34.
So you should know.
Yes.
Very easy calculation, no? So you should 34. Then they also told us that if you move further one standard deviation, then what's going to happen?
47.
So the total observations from here to here,
95.
95%. That means if we take all the children, 95 of the children will fall here. Here, how many children were falling?
68.
So here is 95. So if I tell you only from mean to here, you should know. If I tell you that how much students fall from one standard deviation to the second standard deviation, only in this area, how much? It is 16%, 16% here. As it was 34%, 34% on either side. So it's a similar one. So how many observations fall here now out of 100? If I have 100 students, how many observations will fall here? So where goes the 5%?
The third one.
How can you do that?
98.
Now, understand my point. Now, it is two standard deviation, two standard deviation. How much observations are outside these two standard deviation? 5. Sure?
Yes, yes.
No, less than.
Isn't it?
Out is the two standard deviation and minus two standard.
Yes, plus and minus.
5.
95 students fall here. I take 100 students. 95 fall here within two standard deviations.
Okay.
How many students remain outside this? 5. So how can I distribute them?
2.5.
So in the two halves, I will take 2.5% here, 2.5% here. Is it correct?
Yes. The first one, how many standard deviation?
One standard. It's written here. Minus 1 to plus 1. This is 95 from minus 2 to plus 2. If I take 3 standard deviation, then it is, if I take another one, 3 standard deviation,
100.
Never had C as B minus. So we have 99.7%
Yes.
total observations. Is that clear?
Yes.
So what is the proportion in plus minus 1 standard deviation?
68.
60% of the observation. Now, understand this very important feature. So 68% within plus minus 1. And plus minus 2, we have total of 95.
95.
You can also break it, 16% and 60%.
Okay.
And outside that, you can say 5%, 2.5% on one side, 2.5% on the other side. Osam, you look confused.
A little bit.
Why is the confusion, please? I said I have taken 100 students. Okay? 100 students, I took the weight. When I plotted this weight on the x-axis, I have 95% students which fall within 2 standard deviations. 68% here, 99.7% here. What is the confusion? Very simple. This is still
If it's 99, Victor, could you repeat it?
99.
Yes?
So up to from minus 2 standard deviation plus 2 standard deviation. The total students which fall in this were 95. Out of 100 means 95% of students fall here. The only remaining is the 5%. So 2.5% here, 2.5% here. So if I calculate this as a third standard deviation, we have 99.7% in the 3 standard deviation plus minus mean plus minus 3 standard deviations. Is that clear?
Yes.
Now, very simple, it's very simple logic. That if I have, now another thing, what is the probability? So I will talk another, this is clear?
Yes, yes.
No confusion here? Now I will move a second step. Now, I have an observation 105, for example. What are the chances that this observation will fall? Understand my question?
Yes, yes.
Will fall within mean plus minus standard 1 standard deviation. What are the chances?
68.
What 68? Say 68% chances are there. Or we can say 0.68. Because the observations which fall within plus minus 2 is 68.
Yes.
So the probability of this value to fall within this is this.
Okay.
If I again talk that what is the probability of this value to fall within 2 standard deviation?
95.
95%.
95% or?
0.95.
Is that clear?
Yeah.
How is the question will come to
I don't know.
answer 34?
What? 34?
Yeah. How could you ask?
Oh, simple. So how will you ask me that this proportion? The same way which you will ask me that how much proportion will be from mean to plus 1 standard. I will not involve the minus 1. That is how you will ask me. Or I may say you plus minus. Then it combines both the 34% on either sides of the mean. So what is the big logic in that? This is not veterinary science. Huh? You know veterinary science? Yes.
105, how it would be 68?
For example, what is the proportion of the observations which fall here? 68%, is that clear?
Yes.
Now I am asking you, what are the chances of any value? For example, 105, I may say for 200, that it will fall within standard mean. This is mean. I have given the wrong symbol. Mean plus minus 1 standard deviation. What are the chances of this? Because the observation is 68.
Yes.
So I have 68% chances.